The equation of every straight line can be represented by the equation y equals to mx plus a c. Now, this is the general form of every linear function or every linear equation. Y is equal to mx plus a c, and m is the gradient of the straight line. So m is the gradient, or sometimes we may call it the slope. M is the slope of the straight line, and c is what we call the y-intercept. C is the y-intercept. The y-intercept is simply the value of y where this line is cutting the y-axis. If we have a Cartesian plane, let me draw a sketch of a Cartesian plane here. If this is a Cartesian plane and we have a straight line, that is my straight line. The constant c is actually the value of y at this point. This is where we have our c. That is what it means. And m is the gradient of this line. I will explain how you can calculate m, the gradient of a straight line, or the gradient per se, and how you find a c. Sometimes you are asked to just derive the equation of a straight line, and in that case, what you're simply doing is finding m and c. Once you have your m and your c, you actually have the equation of a straight line. Now, there are different ways that you can get your c and that you can get your m and your c. I'm going to highlight all those ways. I'll start with the situation where we are given 2 points on the straight line. We are given 2 points on a straight line. So you are finding the equation of a straight line given 2 points. Let me write example of the question. Find the equation of a straight line passing through now you have these points 1 and 3, 1 and 3, and 2 and 4. These are coordinates. These are the coordinates of these points. Obviously, if you understand your coordinate geometry, it means this is an x and this is a y. This is an x and this is a y. Okay, I'm going to give my points names. The first one is going to be point 1, which means I'll have x1 from here and y1 from here. And this is point number 2, which will give me x2 and a y2. I want to find the equation of this straight line passing through these 2 points that I'm given. As I said, when you are looking for the equation of a straight line, you are essentially finding your c and you are finding your m. Let's start by finding m, which is the gradient of the line. M, I want to use a different pen here. M is equals to change in y over change in x. That is the formula for finding the gradient. Change in y over change in x, or delta y over delta x. Please here be consistent. I'm going to write the formula. So it will be y2 minus y1 over x2 minus x1. x2 minus x1. It doesn't matter whether you start by you're saying y1 minus y2 and x1 minus x2. All we need is consistency. If you're using these points to be the ones subtracting the points at 1, be consistent. y2 subtract x1, then x2 minus also should also subtract x1. If you choose to say y1 minus y2, you should make sure you also say x1 minus x2. All that's very important. They should be consistent there. Consistency. Let me now substitute. My y2 is 4. My y1 is 3 over my x2 is 2 minus 1, which is my x1. I punch in my calculator. I get 1. Because 4 minus 3 is 1. 2 minus 1 is 1. So I get 1. It means I have my m, which is 1. I want to find the constant c. There are two ways. I'm going to explain the two ways. The other one is substituting for y, m, and x from one of the points. Okay, let me write this. We know that y is equals to mx plus c. We want to know our c, so we can use any of these points. I can use this point here or this point. I'll take my x from this point. I'm going to use point number 1. In this example, I will use point number 1. So I'm going to take my x from point 1 and my y from point 1 and my m. I put them into this equation, then I find c. That's one of the ways that you can use. So y here is 3, m is 1, our x is 1 plus a c. So from here we can solve for c, which means c is equals to 2. 3 minus 1, we take this one this side. 3 minus 1, it gives us a 2. So I have my m, I have my c. It means I now have the equation of the line. Therefore, which is my final answer, therefore y is equals to m, which is 1, x. We don't write 1. If it's 1x, we just write the x. So y is equal to x plus a 2. This is my answer. In most cases, when we are marking this question, we mark you, we give you some marks for getting the gradient. We give you some marks for getting the c, and obviously a mark for writing your final, the final equation of the line. This is one way that you can do it. I'm going to show you another way of getting the equation of the line without explicitly finding your c. This is another way. Let me take out this. I'm going to wrap out this, yes. All right. We already have our m. I'm not going to calculate m again. I just want to show you how you do. We know our m is equals to 1. We have it, but we don't have our c, but we still want to find the equation of a straight line. This is another way that you can do. You use this equation. It is called y minus y1 is equals to m x minus x1. All you do here, once you have your m, you take one of the points that you're given, you substitute them for y1 and x1, and you rearrange. Your c will just come out automatically. Let's do that. So we have y here. Y minus, I want to use a different pen for my substitution. I want to use point number 2. You can use any. You can use point number 1 or you can use point number 2. I want to use point number 2 in this case. So y1 is the y value at point number 2, which is 4. And my m, I found it's 1. We know our m is 1. So I'll write 1 for m. I put an x. And then my x1, I'm using this point here, point number 2. So I'm going to take 2 as my x1. So minus 2. I substituted into this. Once you do this, you can now rearrange. C will just come out automatically. So this is y minus 4 equals to x minus 2. Then we're going to take the y that side, which means y is equals to x minus 2 plus 4. Okay. If we do this, guys, we get the same answer, that y is equals to x plus a 2. So this is another way of getting the c without really getting the c explicitly. You just get your m, then you come to this formula here, you substitute one of the points that you're given into here and simplify. Then you get your equation of the straight line automatically. Your c is 2, you see it here, it's now here. This is how you find the equation of a straight line if you are given 2 points. I want now to go to another situation where you want to find the equation of a straight line, but you are given another point, another line parallel to that line. So you're given a point and another line that is parallel to the line that you're looking for. I'm going to write the question, how such a question will look like is the line y is equals to, 2 over 3x plus 4 is parallel to a line okay, I missed the line here. So the line, you know already. So the line y is equal to 2 over 3x plus 4 is parallel to a line passing through 0, 4. Passing through 0, 4. So we have here a point on the line. This is a point on the line, and we are also given another line that is parallel to it. So we want to find the equation of the line that is parallel to this, and it also passes through this point. We want to find the equation of that line. Now, when it comes to mathematics and science, every word that we put in our questions usually have a meaning, and it has a significance there. The word parallel here is telling you that these two lines have the same gradient. If two lines are parallel, they have the same gradient. It means that. And already we're given this line here. From here, we can find m, the gradient of this unknown line. See, we don't know this line, but we can know it. We now know its gradient. So I'm going to write the solution here. From here, I can go straight to say m is equal to 2 over 3. Guys, you can only deduce that m is equal to 2 over 3 if your equation is in standard form. And if you look at this equation here, it's already written in standard form, y equals to mx plus c. So we can actually see what is our m. And that m is equal to the m for the unknown line that we're looking for, because the two lines are parallel. So we have our m already. Half of the work is done. Now, but we don't have our c. I said in this case, we have to rely on this equation. Let me write this. We have to rely on the equation that y minus y1 is equals to m x minus x1. Okay, we have our m, 2 over 3. We deduced it from the line that we were given. For x1 and y1, we use the coordinates of the given point. So the x from the point becomes our x1. The y from the point becomes our y1. We just substitute there and rearrange, and we have the equation of our line. Let's do that. So this is y minus our y1 is 4. This is equals to m. We know our m is 2 over 3 times x minus x1, which is minus 0. From here, guys, we get that y is equals to, if we multiply here, we get 2 over 3x. We take the 4 that side plus a 4. This will be the final equation of that line. This is the final equation of that line. In fact, if you look here, we have the same equation that we had before. It is simply telling you that these equations are on top of each other. In fact, this equation itself passes through this point here. So it's actually the same equation. It's the same equation here. Check if you haven't made any mistake. I don't see any mistake. We have our 2 over 3 here. It is here. And we took it from the given equation, which is parallel to it. We also substituted our y1 is 4 and our x is 0, and we rearranged. We got the solution. Please don't start saying, whenever I'm given this is parallel, the same equation. No, this was just coincidence. In other words, what we have here is something like this. We have, it's like I draw a straight line. I draw a straight line, and on top of it, I put another straight line. See? So it's like the same line here, the same line, and they're parallel. So they're sort of like superimposed on each other. It's the same line that we're talking about here. Anyway, this is the solution. This is the answer. Maybe I should do a different question. I want to do now a different situation. Please just know how we do this. So here you are given a line parallel to it and a point that it passes through. You're given a line parallel to it and a point that it passes through. I'm going to do the last situation. So the first one, we were given 2 points. The second one is this one, where we're given a line parallel to it and another point. I'm going to do the third situation, where we are given a line perpendicular to it and a point. So I'm going to give a line perpendicular to it and a point. All right, let's do that. So equation of a line perpendicular to perpendicular to 3x plus 4y minus 6 equals to 0. We want to find the equation of a line that is perpendicular to this line here, passing through minus 2, minus 2, minus 2, minus 2. So this line that we're looking for is perpendicular to this one, is perpendicular to this equation that we're given, but it also passes through this point. So we have the equation of a line perpendicular to the unknown line, and we also have a point through which this unknown line is passing through. All right, let's do this. Now, the word perpendicular means these two lines are meeting at a right angle. That's what it means by perpendicular. So the two lines are perpendicular to each other. What do we know about perpendicular lines? We know that if we multiply their gradients, we get minus 1. So if we multiply m1, the gradient of the other line, times the gradient of the other line, we should get minus 1 if these lines are perpendicular. So this is some knowledge that you should have when you're dealing with this kind of equation. From the previous one, I said if two lines are parallel, they have the same gradient. But if two lines are perpendicular, it means if we multiply their gradients, we get minus 1. Now, we don't know the gradient of this line explicitly, until we have rearranged this in standard form. So it is 3x plus 4y minus 6 is equals to 0. Let's make y subject of the formula here. So I'm taking this side, I'm taking this side to the right hand side. I have 4y is equals to minus 3x plus 6. Now to find my y, I divide by 4 throughout. I divide every term by 4. So y is equals to minus 3 over 4 x plus 6 over 4. From here, guys, we can conclude that y is equals to minus 3 over 4x plus 6 over 4 to the lowest terms is 3 over 2. Right. So we know the equation of a straight line parallel to it. I'm writing this in standard form so that we can see our m. Very important here that you arrange your equations in standard form so that you can know your c or your m. Let me rewrite what I have now. Let me rewrite what I have. I have y is equals to minus 3 over 4x plus 3 over 2. This is the equation that I have. And this equation, we know that it's perpendicular to our unknown line. Then it means from here, we can know our m1. So m1 is already here. It's minus 3 over 4. We know our m1. We also know that this line, the unknown line, by the way, the unknown line passes through the point minus 2, minus 2. I'm just writing this. We need this point. Now from here, let's find the gradient of the unknown line. What we know is if we multiply its gradient by minus 3 over 4, we should get minus 1. So if we say minus 3 over 4 times that gradient that we don't know, let's call it m2, we should get minus 1. From here, we solve for m2. Therefore, m2, the gradient of this unknown line is 4 over 3. It's a positive 4 over 3. In short, if two lines are perpendicular, the gradients are simply the inverse of each other with different signs. So if the other one is minus 1 over 2, the other should be 2 over 1, but with a different sign. This one is minus 3 over 4. It means the other gradient was supposed to be 4 over 3, just with a different sign. So you take the inverse of this and you change the sign. That's all. That's how you find the gradients of lines that are perpendicular. All right. Now we have our m, the gradient of that line. We have it here. We have a point on the line. We can now use this equation again. Y minus y1 is equals to m x minus x1. This is a very powerful equation. See, this is a very powerful equation. Once you have your gradient and you have a point, you just substitute into this equation and then you rearrange and get your final equation. So our y minus our y1, we're taking the y1 from the given point, which is, I'm sorry, this should be minus 2. By the way, this is minus 2, minus 2. This point is minus 2, minus 2. So y minus y1, which is minus 2, equals to m, which is 4 over 3, x minus, our x1 is minus 2. We close the bracket. Now we just have to simplify this. So this is y plus 2, 4 over 3x, minus 2 becomes a positive 2, and we are multiplying that by 4 over 3. So 4 over 3 times 2, we get 8 over 3, positive 8 over, so plus 8 over 3. Then we finish up by just subtracting minus 2 from here, both sides. So y is equal to 4 over 3x plus 8 over 3 minus your 2. So if you say 8 over 3 minus 2, now you get that the value of c is going to come from here. This is the value of our c. 8 over 3 minus a 2. I get 2 over 3. 2 over 3. That is my c. So it means my final answer is simply y is equals to 4 over 3x plus 2 over 3. This is the equation of the unknown line. All right. I just want to give you a summary of the important things that you need to know when you are finding the equation of a line. One, you need to know that m, which is a gradient, is equals to change in y over change in x, which means y2 minus y1 over x2 minus x1. You need to know this because when you're finding the equation of a straight line, you need to find the gradient. You have to know the gradient. Another thing that you need to know is that parallel lines have the same gradient, have the same slope or gradient. You need to know this. That is the second and very important thing to know when you're dealing with equations of straight lines. You should know that parallel lines have the same gradient. And we go to 3. The third thing that you should know is that if two lines are perpendicular, so I'm going to say for perpendicular lines, m1 times m2 is equals to minus 1. If you know one of the gradients, you can easily deduce the other one. Because if you multiply the two gradients, you should get minus 1. But I've given you a short way of knowing it. Just know that it's the inverse of the other with a different sign. If the other one is minus 1 over 2, the other should be 2 over 1, which is positive. If the other is minus 3 over 4, the other one will be 4 over 3. See the inverse with a different sign. That's all for perpendicular lines. That is the third thing that you should know. Then maybe you should also not forget this formula here, because it's going to be a very useful formula. Formula y minus y1 is equals to m x minus x1. You are going to rely on this formula a lot. Maybe the last thing that I should mention is you can only point out your c and your m if you have written the equation of a straight line in standard form. So first of all, it should be written in the form y equals to mx plus c. Then you can pick out that this is your m, your gradient, this is your c. If it is not written in that format, you will not be able to see what is your m and your c explicitly. It will not be easy to deduce that. So please, every time you're given the equation of a straight line, try to write it in the standard form where you have y on one side and then the other stuff on the other side. And you can now see your m and your c clearly. I think that's all. If you have any questions or any comments, you can just write in the comment section below. I will respond to you. Subscribe to the channel and thank you for watching. Keep watching.